So this question is asking to identify the spectral components in this signal, cosine 2t minus 2 sine squared t. So obviously it's a periodic signal, so it'll have discrete spectral components. And we can take these one by one. So for the first one, we can identify the spectral component just by looking at the frequency there. So you can look at the argument there, the coefficient of t. So that's our frequency of 2 radians per second. So the actual frequency in hertz will be that divided by 2 pi. So that's our first component at 1 over pi hertz. So that's one component. Are there any others? So we'd look at this. Now, because it's a sine squared, we need to remember that that simplifies into 1 minus cosine twice the angle. So we end up with the same component again. But it also brings up this DC component. So this constant 1, that's a DC component. That is DC, it's a constant. So what's the frequency of this DC component? This will show up at 0 hertz. So in our spectrum, in our spectral representation, where we have frequency here, we will have some component here. And then we'll have a component at 1 over pi. So that'll be our fundamental component. So that'll be 0, and that'll be 1 over pi. But there won't be any harmonics. All the harmonics will be 0. So there aren't any higher multiples. So we simply have these two components. So that's the final answer here. What are the spectral components of this signal? Well, there are two spectral components. One at 0 hertz and one at 1 over pi hertz.